So this is 5.2 multiplying and dividing radicals. So last time we were working on adding and subtracting. Now we're going to work on multiplying and dividing. So multiplying radicals is super easy. You just multiply the coefficients and you multiply the radicands. You can only multiply radicals if they have the same index. So that means you cannot multiply a cube root with a square root. But you can multiply anything as long as they have the same index. So then if we look at this, we are going to multiply -3 by 4, so that'll be -3 multiplied by 4, and then we have the square root sign, and we're going to go 2x multiplied by 6, and then we get -12 root 12x, but this is not a full answer because we can still break this down. Remember, this breaks down to the square root of 4 times the square root of 3x. This changes to 2, comes to the outside, changes to -24 root 3x. With something like this is a little trickier, but all you have to do is apply slowly. So this 7 applies here and here. So then 7 multiplied by 5 root, and then minus 7 that's a weird looking 7. 7 multiplied by 6 root, and then root 3 multiplied by root 5, so 3 multiplied by 5, and 3 multiplied by 3. So this gives us 35, root 15, minus 42, root 9. So then that becomes 35, root 15, minus 42 multiplied by 3 to give us 126. Always check to make sure that it's simplified as far as it can go. Our next one is a binomial multiplied by a binomial. So make sure to go slow. So 8 root 2 here. So 8 multiplied by 9, root 2 multiplied by 5 here. So plus 8 multiplied by 6, root 10 multiplied by 2. I'm just going to keep going, and then this becomes -5 multiplied by 9 root 5, so -5 times 9 root 5 minus 6 multiplied by 5 root 10. Okay? So this becomes 72 root 10 plus 48 root 20 minus 45 root 5 minus 30 root 10. Now we check to make sure that it's all broken down, and I think this is the only one that's not, because that breaks down to root 4 times root 5, so 2 multiplied by 48. So that gives us 72 root 10 plus 96 root 5 minus 45 root 5 minus 30 root 10, and then you have to simplify if you can. So here and here we can combine, and here we can combine. So then that leaves us with 42 root 10 plus 51 root 5. So slowly, go slowly. Make sure everything gets written out and you know exactly where your train of thought is going. Okay? I'm just going to extend my page down so I have enough room for this next one. So for D, it is 9 cube root 2w bracket cube root 4w plus 7 cube root 28. Okay, so then multiply, and remember there's technically a 1 there, so don't be afraid of what's happening there. So 9 cube root 2w multiplied by 8w plus 9 multiplied by 7 2w multiplied by 28. So that leaves us with 9 cube root 16w squared plus 63 cube root 56w. This can be broken down into the cube root of 8, which is 2, multiplied by the cube root of 7w. So then 2 multiplied by 63, and we get, oh, this can break down here as well. So this is 8, the cube root of 8, times by the cube root of 2w squared. So then 2 multiplied here. Oops. So that leaves me with 18 cube root w squared plus 126 cube root 7w. Okay, now we are going to apply radical multiplication. That's on the next step. So this is one of the word problems in the textbook. So an artist creates a pattern similar to the one shown, but he frames an equilateral triangle inside of a square instead of a circle. The area of the square is 32 centimeters squared. Express all answers in simplest form. So if I sketch this first, that's my triangle. It's a square, so these sides are all equal. So this is square root 32, square root 32. And I know that because the area of a square is equal to 32. Therefore, if area of a square is equal to side squared, that each length, so S should equal the square root of 32. Now, if I want to find the exact perimeter of the triangle, the perimeter is equal to length times length times length, or 3L. And then if we break this down, this breaks down into 4 root 2. So this becomes the perimeter is equal to 3 multiplied by 4 root 2 to give us 12 root 2. Okay? Determine the exact height of this triangle. Well, there's 2 different ways to do it, but I'm going to do it with Pythagorean theorem because I like Pythagorean theorem, but you're more than welcome to do it using sine, cosine, tan. Remember, this would be 60 degrees here, and this would be 30 degrees here. It doesn't matter which way you do it, as long as you use the right measurement. So if I'm trying to find height here, height squared is equal to a squared minus b squared. Remember that this is 2 root 2 because the whole side length here is 4 root 2. So then height is equal to the square root of 4 root 2 squared minus 2 root 2 squared. Now the nice thing is that we kind of just apply this in. So the square root of 16 times 2 minus 4 times 2. So the square root of 32 minus 8, which gives us 24. So then the square root of 24 breaks down into the square root of 4 times the square root of 6. So 2 root 6 is the exact height of the triangle. And the exact area of the triangle, we do area is equal to base times height divided by 2. So 4 root 2, the base, multiplied by the height of 2 root 6, all over 2. This gives us 8 root 12 over 2. So 4 root 12. This breaks down into root 4 times root 3. So 8 root 3. Okay. Now we go on to dividing radicals. So when dividing radicals, divide the coefficients and then divide the radicands. We can only do this when they have the same index. A rational in simplest form does not have a radical. in the denominator. If necessary, we must rationalize the denominator always, and I'm going to show you what that means. So the nice thing is that when they have the same radical like this, we just extend it. That is a skill that we can do from grade 9. So 24 divided by 3 gives us 8. X squared minus x. So 1x minus x gives us x. And then this breaks down into square root 4 times square root 2x to give us 2 root 2x. Always in simplest form, please. Okay. So rationalizing the denominator means getting rid of this. Now, if I want to get rid of a square root, I have to multiply by square root. So then if I'm multiplying square root by square root, that kind of cancels out these square roots. And that just leaves us with a 2. So then this gives us 4 root 10n over 3 multiplied by 2 to give us 4. Well, this can cancel, so that leaves us with a 2. So then 2/3 root 10n. Okay, same thing here. We need to get rid of the, what's the word? We need to divide first. Okay, so let's simplify. So this cancels here, so this gives us 4/5. And then if we are dividing here, the square root of 6 divided by the square root of 3 leaves us with square root 2. Because if we went like this, here, so 4 root 2 all over 5. Okay, with this one, we can't divide any further, so that means we need to simplify the denominator. So that leaves us with 7 root 3x all over 3x. So it's always making sure that we have it in simplest form. Now, that is when we are dealing with easy stuff in the denominator. Sometimes we have a more complex form like this. So 2 binomial factors whose product is the difference of 2 squares is a conjugate. So when we looked at x squared minus 25, we had x plus 5 and x minus 5. These guys are conjugates of each other. So if I want the conjugate of this, I'm looking to multiply by 4 plus root 6. 4 plus root 6. And I am doing this so I don't get a middle term. I get the first term and I get the end term. So that would result really nicely, and I'm going to show you how that looks in the first example. So if I'm trying to find the conjugate of this, it's simply 3 minus root 2. Whatever you do to the top, and you must do to the bottom, and vice versa. So then you apply this in. So that's 18 minus 6 root 2 all over 3 multiplied by 3 is 9 minus 2. So then that leaves us with 18 minus 6 root 2 all over 7. Because this cancels here, because a square root multiplied by a square root gets rid of it. For B, we are looking for the 3 root 2 plus root 3. This is 3 root 2 plus root 3. We apply that in. That gives us 15 times 2 plus 5 root 6 all over 9 multiplied by 2 minus 3. That gives us 30 plus 5 root 6 all over 18 minus 3 is 15. Okay. Next one. Root 3 minus 5 root 2. Empty brackets to signify the same thing's happening. So this gets us 4 root 3 minus 20 root 2 plus root 6 minus 5 multiplied by 2 all over 3 minus 25 times 2 to leave us with 4 root 3 minus 20 root 2 plus the root of 6 minus 10 all over negative 47. Now you're going to say, well, that looks more complex. What am I going to do with that? Have no fear. When you start graphing, it's going to make more sense of why we do this. And it's basically when we're looking for what it cannot equal, this guy right here will tell us. Okay, we need to rationalize this denominator. Lucky this one's a lot simpler. It's just root 6. So this gives us 4 root 66 all over 6y cubed. This reduces. This cannot be broken down. This is as far as it goes, and I'll prove it to you. So 66 is just 3 multiplied by 22, which is 11 multiplied by 2. And that means that there is no groups of 2 in there, so we can't simplify it anymore. So this leaves us with 2 root 66 all over 3y cubed. Okay, assignments down below. If you have any questions, please let me know.